Hello everyone, I am Hilalnur Beral. I am a senior student at TED University Computer Engineering Department. And today I will give a presentation about our research topic, virtual reality and augmented reality integration into AEC, Architecture, Engineering, Construction Industry. Virtual reality and augmented reality technologies are considered to be one of the most influential innovations anticipated in the near future to transform the architecture, engineering, and construction industry. Their applications have already started to make noteworthy gains around the world, and it is expected that their use will increase moving forward. In the construction industry to date, VR and AR have effectively been used in scheduling construction projects, for monitoring project progress, in training workers, time and cost management, and in the time management of quality and defects. Although there are similarities between the two technologies, there are certain differences that differentiate the two and provide certain advantages depending on the purpose. As the definition of AR has developed as an extension or modification of VR, AR is closely related to VR. It incorporates real-life and computer-based scenes and images by superimposing the view from a real-world physical environment with the objects from a virtual world to provide a seamless and enhanced view of the world. VR goes a step further with 3D visualization. It is generally defined as a 3D synthetic environment or structure generated by computers that gives the user a sense of being immersed in a real world. So what are the shortcomings of 2D design and execution in construction? Traditionally, construction projects have been designed and executed in 2D, first by hand-drawing plans and later by computer-generated 2D drawings. Nonetheless, there still is an inherent problem with using 2D for construction projects, as technical personnel are required to visualize drawings and special relationships between building elements and translate into 3D and effectively communicate with other stakeholders. A further problem area is poor portability and incorrect handling of drawings. AR and VR technologies have found applications in a wide variety of industries, including engineering, healthcare, education, military, sports, entertainment, and cultural heritage. AR can be used for classroom-based learning in topics such as chemistry, biology, physics, astronomy, and other fields of higher or K-12 education. It can also be used in higher education and especially in engineering to improve students' understanding of mechanisms of systems or machinery. And in healthcare, both AR and VR with a head-mount display are used to display medical information and pictures in tandem with a procedure, either to provide surgical training for trainees to simulate an operation and aim to reduce the incidence of errors, or for education purposes. AR in construction. Augmented reality enables information that is captured in the physical world to be viewed on site and is thus necessarily consistent with the needs of the construction site. AR systems are used to capture and distribute data to field users. This also reflects the means of contact between project members and knowledge on the project. Benefits of using AR in construction projects are scheduling and project progress tracking, quality and defect management, time and cost management, employee training, and safety management program. Now we are in construction. Immersive environments provide opportunities for better communication between stakeholders, better spatial understanding of virtual designs, better understanding of design decisions, and recognition of design problems that would not be otherwise found. And it can also predict human building experiences that can feed designers and researchers to accurate user experience data. VR technologies are gradually incorporated into the construction industry with these advantages. These technologies can be used for worker training, safety management system, progress tracking, labor management, defect and quality management, and project visualization. It is very suitable for providing realistic and cost-effective virtual environments for security education. And there are some primary needs for VR development system. The development of VR systems has certain technical and non-technical needs. Hardware is important for successful development and use of VR technologies on the technical side. A high frame rate and low latency are required in effective immersive environments. Processors and special graphics hardware can be useful for VR system. The development system should have little overhead to allow the hardware to operate at its maximum efficiency. So what are the capabilities of the environment? Hardware abstraction. Help for the hardware needed is important, but how well the toolkit describes the hardware interface information is just as essential. Although a less standardized interface may be better suited to the unique features of the computer, the standardized interface makes the program more versatile and simpler to update, manage, and understand. Locally distributed application. In addition to raising the application frame rate, delivery has other advantages. Display channels available for the application or increasing the number of input devices. It enables the use of additional computers for simulations and other computer-intensive activities. And distributed environments. For distributed systems connecting multiple computers, the idea of connecting machines and users to distant locations around the network opens up the possibility of communicating in a virtual world. And rapid prototyping. It is important to be able to run and interact with the application without using any special equipment, because most development groups can only access 1 or 2 full VR installations. Otherwise, it is possible for developers to spend a lot of time waiting for the devices to turn on. And last, the runtime flexibility. VR applications usually take a long time to start. Processes must be created and configured, then the hardware is started and databases are loaded. When a small change is made, the time required to restart an application can render the system inapplicable. Now I will talk about the current VR softwares. There is numerous software commercially available in the market. These tools have been developed mostly by different firms and each has a specific niche together with limitations. I want to start with Iris Performer. It's a high-performance graphics API for machines running Silicon Graphics Inc. It can be used to create high-performance VR applications. And Performer is a library of graphics based on C and C++. Iris Performer is a runtime programming interface with an in-memory scene representation. And there are some strengths. Tool has visual simulation features such as billboard geometry, light points, and clip texturing that are valuable for the development of VR applications for visual simulation. And there are some drawbacks. Limited platform availability is one of them. Iris Performer can work only in SGI machines. And limited hardware support is another drawback. There is no support for other input devices except for mouse and keyboard. Now, World Toolkit. WTK is a VR library written in C, and there are C++ wrappers. It handles the specifics of reading sensor input, rendering scene geometry, and loading databases. It provides good support for most visual and acoustic output configurations, but don't include force output. So what are its strengths? It is widely used and it is closed platform, and multi-pipe support is one of the strengths. The SGI version supports multi-pipe applications. This allows Word Toolkit to control caves and similar devices. And there are some drawbacks. Device abstraction is one of them. If there is a hardware update, the program code has to be modified and recompiled. And performance is another drawback. Some VR libraries and libraries based on Iris Performer are not performed by Word Toolkit. And Avocado. It is a VR software system platform for their VR applications based on Iris Performer. C++ is used as a programming language to describe two types of object classes, nodes and sensors. Nodes have an object-oriented scene graph API that allows complex geometry to be represented and rendered. Sensors provide an interface to the real world that imports data from external devices into an application. So what are the strengths? Scripting is one of them, rapid prototyping of applications, in other words. And fields. Creating powerful application is made easy with the data stream network. And extensibility is another strength. Objects with node, sensor, and device are very easy to extend. So there are some drawbacks. Cross-platform is one of them. It works only SGI platforms. And scripting is another drawback. Scheme is not a well-known language. That's why choosing it as a language of scripting may be a challenge. It may also be challenging to understand the functional languages. Now I will talk about the limitations and drawbacks. Although many people are familiar with simulated AR images through the television and movies media, convincing a user to wear a system also means addressing a number of problems. Fashion, personal appearance, and privacy concerns are among these problems. There are some technical challenges such as binocular vision, need for high resolution, depth of color, contrast, field of view, and depth of focus. If we compare the AEC industry with other industries, the AEC industry has been slow to adopt AR/VR technologies. This is partly due to the lack of feasibility studies that examine the actual potential implementation costs and potential production increases. The applications, potential benefits, and limitations of VR and AR technologies in the AEC industry have been covered so far. The high cost of AR and VR technologies and the general lack of AR and VR expertise in personnel are two major challenges limiting further dissemination. Nevertheless, the non-technical conveniences and technical superiority in improving safety management, time and cost management, and defect and quality management provided by their use are too valuable to ignore. Their contribution towards scheduling and project progress tracking are also noteworthy for the field of construction. And thank you for your attention. If you have any questions, I can answer. Otherwise, that's the end of my presentation. Thank you so much for listening.